Okay, now we're going to look at simplifying rational expressions. So we know how to simplify and multiply and add and subtract and divide fractions. So we should be able to now apply this to the same ideas to algebraic expressions. So let's start off with something very simple, like x over x equals what? Okay, now, well, the automatic thing that you want to say is, well, a number divided by itself is just 1. And that is true. So in pretty much every case you can think of, it's 1, except for when x equals 0. Because you cannot divide by 0, and 0 divided by 0 is undefined, we have to do this. X cannot equal 0. So the left side of this equation is not just equal to 1. In order to be true and equal, it has to be equal in all situations. So we have to eliminate the situations where it's not true. Okay, so this is called a restriction. So this is true, x over x equals 1, as long as this restriction is satisfied. X cannot equal 0. Okay, so what if we tried something else that's a little more complicated? How about x squared plus 3x divided by 2x squared plus 8x. Well, we notice that the top and the bottom is going to have some common factors here, one that's x. So let's factor that out. So let's factor the x out of the top, and you get x plus 3 is left. That's the common factor of x. And the bottom, we've got a common factor of 2x. And then we have x plus 4. Well, we can cancel out the x's, but we have to write in that x cannot equal 0. So we would have x plus 3 left over on the top and 2 times x plus 4 on the bottom. But now we have to write down that x cannot equal 0. And now that equality is true. Okay, so in this one here, it's obvious that x can't equal 0 because it's written in there. Here, it's not obvious. Now there is another restriction on this, that is x cannot equal -4. But because it's obvious in the look of this, we don't have to write it down. However, if you were asked a separate question, state all restrictions of this rational expression, then you'd have to write down, from here, you'd have to write down x cannot equal 0 and x cannot equal -4. Now the reason x cannot equal -4 is because if you plug in -4 in here, you're going to get 0. And the problem is you'd then be dividing by 0, which is not allowed. So let's try another one. How about x squared minus 9 over x squared plus 6x plus 9. Now, hopefully you remember how to factor these. The top one is a difference of squares. It's x minus 3, x plus 3. And the bottom one is a perfect square. Half of 6 is 3, 3 squared is 9. So that's a perfect square. So that ends up being x plus 3 squared. So in this case here, we can cancel out an x plus 3 on the top and the bottom because that's a common factor. So we can write that as x minus 3 over x plus 3. So basically we're canceling out this 2 and we're canceling out this x plus 3. And what we have left is the x plus 3 on the bottom. Now, x could not equal -3 here because if it was, then you'd be dividing by 0. So because we've canceled it out, we might want to write down x cannot equal -3 here. It wouldn't be wrong, but it's not necessary, and it's not the most efficient way to do this. So we can leave this like this because this x plus 3 is still on the bottom, and x is obviously not allowed to be -3. Okay, but what if it was more like this? So let's do x squared plus 8x plus 16, and then x squared minus 16. Now the top again is a perfect square. X plus 4 squared. Half of that squared is 16. And the bottom, difference of squares, so it's x minus 4, x plus 4. Okay. Now we can do the same thing. We can cancel out one of the x plus 4's here. So cancel out this one and one of those, and you end up with x plus 4 over x minus 4. Now in this case, part here, x cannot equal 4 or negative 4 because that will make the bottom 0. You can't tell in this case that x can't equal negative 4. You can tell that it can't equal 4 because that would make the bottom 0, but you can't tell that x can't equal negative 4. So we have to write that in as a non-obvious restriction. So x cannot equal negative 4. Okay, and now we have a true statement. Okay. What if we tried something more complicated here? How about x squared plus 5x plus 6 times x squared minus 25 all over x cubed minus 3 x squared minus 10x. So to simplify this one, well, we have a few quadratics to factor here, a couple of quadratics, and then we have a cubic. So let's just start factoring, see what we get. So this one, two numbers that multiply to 6 and add to 5. Okay, so that'd be 3 and 2. So you're going to change that to x plus 3 and x plus 2. So that's this part here. And then we have x squared minus 25. So that's going to be x minus 5 and x plus 5. And that's the top factored. Now the bottom, well, we have a common factor of x. So let's take that out. Then we have x squared minus 3x minus 10, and we have now a quadratic on the bottom. So we write this out, x plus 3, x plus 2, x minus 5, x plus 5 on the top, over x, and then the bottom, well, two numbers that multiply to negative 10 and add to negative 3 are going to be 5 and 10. Okay, so we're going to write that down as, or 5 and 2, sorry. So we're going to write that down as x times x plus 2 and x minus 5. Okay, so the negative 5 times 2 is negative 10. Negative 5x plus 2x is negative 3x. Now we notice that there are common factors here on the top and the bottom. So we can cancel this out and this out. And we can cancel this out with this. And what we have left is x plus 3 times x plus 5 all over x. And now it's not obvious, so it was obvious here that x could not equal negative 2 and x could not equal 5. It's not obvious here, so we have to write it in. So x cannot equal negative 2 and 5. Now x also cannot equal 0, but that's still obvious. Okay, it's still in the expression. And so that's it for simplifying rational expressions. Next we're going to look at multiplying rational expressions.